Students of M.Sc Chemistry from semester 1 of Physical Chemistry and respected listener, a very good afternoon and welcome all of you to today's lecture. Students of M.Sc Chemistry, I am going to present today a newly topic. The title I have mentioned on the blackboard, the dynamic of chain reaction of hydrogen-bromine reactions, which is selected from M.Sc Chemistry, Physical Chemistry of paper 3, chosen from that is of unit 3rd, titled as that is of chemical dynamics. Once again I repeat, the topics, the lecture I am going to deliver to present today, I have mentioned on the blackboard the dynamics of chain reaction of hydrogen-bromine reactions, and its necessarily postulates, necessarily derivation and equation and expression I will teach you today. Students of M.Sc Chemistry, first of all, I would like to teach you about, I would like to focus it's regarding previous last two important theory, collision theory and that is of activated complex theory, which is mainly to define today's chain reaction of H2 and Br2. First of all, I would like to focus to repeat some important points of that is of collision theory. In collision theory, that is of in collision theory, students have to calculate the value of velocity of the reaction by the multiplication of two important factors, that is of a collision factor, which is symbolized by that is of ZAB and which is defined in any reaction vessel per second per centimeter cube. The number of colliding or active molecules is known as that is of colliding coefficient or that is of colliding that is of factors. And this that is of colliding that is of collisions factors is when is now multiplied with that is of activated surface area mathematically, which is calculated in terms of e to the power minus e upon RT to give the final value of that is of velocity of the reaction using that is of activated complex theory. It has also been considered to derive the velocity of the reaction using that is of collision theory, the behavior, nature of the colliding molecules to act just like that is a rigid dynamic behavior. And so on the behalf of overall postulate, finally we derive amazing, incredible reactions to calculate the value of velocity of the reaction using that is of collision theory. In first one case, when that is of colliding molecules to possess different concentration nature, which the concentration which are expressed in terms of that is of N and that is of NB. The drawback, so in order to explain about the drawback failure of collision theory, that is collision theory simply is applicable for simple bimolecular gaseous reactions to occur, such as 1 mole of H2, 1 mole of I2 to produce twice mole of that is of HI, 1 mole of N2 to react 1 mole of O2 to produce twice mole of that is of NO. So these are very simple bimolecular gaseous reaction in which when we calculate the value of velocity constant to give the same value, by all means theoretically, practically and experimentally, K theoretically will give to the same value of K practically. But on the other hand, when we apply the collision theory for that is of typical reactions, dense reactions such as polymerization of ethylene, polymerization of that is of 1,3-butadiene, in such simple reaction, in such that is of a typical reaction, when we calculate the value of rate constant theoretically, practically, experimental to give the different value. And in order to remove these failureness or drawback, we need a modified collision theory by the multiplication of a new factors which is known as that is the probability factor, and is symbolized by that is of P. So these were all the overall discussion regarding to define about collision theory. Now second one, the theory which is mainly concerned to derive, to determine the velocity of the reaction, activated complex theory, which is also known as transition state theory, or that, or in another name is that is of absolute reaction rate theory. The important postulates I would like to repeat among the students. The activated complex theory is firstly studied by that is of Eyring, Polanyi, Evans in 1935. For the derivation of rate constant or velocity of the reaction using that is of activated complex theory, it has been assumed at normal condition the nature, the state of the molecules one can classify into that is of normal molecules. After providing the temperature, the normal molecule now to take the form of active molecules, these various active molecules now will react by the explosive, by the treatment or by the reactions of these active molecules to produce an intermediate species which is known as that is of activated complex here. There are so many characteristics of activated complex. Activated complex also play an extremely contribution to explain the kinetics dimension, the dynamic of hydrogen Br2 chain reaction. So it becomes essential to describe the important features of that is of activated complex here. When a graph is plotted between that is of potential energy along with that is reaction coordinate, in such a position, the dynamic profile which we have plotted in our previous video, on the behalf of our previous video, last video, I would like to explain about the important features of activated complex here. That is the first one, characteristics of activated complex here. It possesses the higher the potential energy, both of the reactant that is of the product here. Next one, characteristics of that is activated complex. The energy between active molecules and that is activated complex is known as a specific kinds of energy which is known as that is of energy of activation and is symbolized by that is of EA. Also, there is established a quantitative thermodynamic relationship between active molecules and that is activated complex, and it happens, these overall mechanism reactions undergo, it happens by means of a first types of the constant which is known as that is of equilibrium constant and symbolized by that is of K star. In another characteristics I would like to explain about activated complex, its concentration is expressed in terms of large bracket to present in terms of active mass and symbolized by that is of star. Now there is also a special kinds of energy to produce from that is of a kinetic or dynamic profile the reaction or the energy between the reactant and product to give the difference between the energy of reactant and product to give a newly types of thermodynamic heat or energy which is known as that is of enthalpy and symbolized by that is of del H. Finally, the emission of activated complex is also possessed transient distinct unstable species in which one bond is partially that is of breaking and another one that is partially that is of forming here. So such unstable species, finally the emission of the energy finally to convert into that is of a product. These were the overall important characteristics of activated complex here. According to that is of activated complex theory, the calculation of velocity of the reaction depending upon two types of the quantity here, that is equals to active mass of activated complex here, which is its concentration is expressed in terms of star. Second one, the decomposition of that is of frequency. Now in order to calculate the value of activated complex and velocity of the reaction using that is of a transition state theory, it becomes to know to calculate firstly the value of AB star, which is expressed the concentration of activated complex in terms of active mass. So it has been calculated directly from B.Sc part 1 using that is a simple kinetics theory and you have studied. And second one, that is a frequency or nu is calculated decomposition of frequency using that is of E is equals energy of quanta photon is equals to h nu, and by the separation nu to give to by the separation when we calculate the value of nu, and when AB star is multiplied nu to give the next amazing equation regarding to define the velocity of the reaction here. Also equation number 9, we have also derived equation number 9 in our previous video, in which equation number 9 here to possess that is of three types of the constant. First one K2 which is defined the second order at constant, next one constant which is defined that is of equilibrium constant, and last third one constant which is defined that is a Boltzmann constant. When gas constant R is divided by that is of Avogadro number to give the value of Boltzmann constant here. Now I say that is of this one equation number 9, and you know from B.Sc part 2 unit 3rd equilibrium there is a quantitative relation between Gibbs free energy del G star along with that is of a thermodynamic equilibrium constant. One can write in the form of del G star is equals to del H minus R, that is of R that ln that is of K star, and after the separation in E base, finally the equilibrium constant I am writing here in terms of, in equation number 12, K star is equals to minus E del G star divisible by that is of RT, and you also studied the relation Gibbs free energy enthalpy del H, and that is of del H star in that is of equation number 3. In equation number 3, the relation between that is of Gibbs free energy with that is of enthalpy and that is of entropy, directly you have to pick, you have to use here that is of del G star and del H star, T del H star, all the star, to denote, to define the overall the thermodynamic quantity based on that is of activated complex theory. Here del G, I would like first of all to explain about here. That is of del G star denote the change in Gibbs free energy for activated complex. Similarly, change in enthalpy del H star, change in enthalpy for activated complex here, and that is of activation of entropy, which is symbolized by that is del H star to define activated complex here. Say that is of equation number that is of 13 here. Now by when we multiply here equation number 3, 5 and 9, when we substitute the value in next term equation number 13 in equation number 12 here, now after solving and take the log in that is of E base and we separate finally the value. So automatically, ultimately, we derive a special equation in terms of wet rate constant K2, which is directly to divide into two different value in terms of equilibrium constant, which is symbolized by that is the K star, and next one that is the thermodynamic aspect as we have derived in our previous video. It is the first achievement to define using that is activated complex theory. Now it becomes essential since two types of the theory, that is the activated complex theory and collision theory. These were the two important fundamental theory to explain the rate of the reaction or rate law. So it becomes essential to compare which theory is superior. So it can be compared by using the fundamental equation derived from that is of rate using that is of collision theory as well as that is of activated complex theory. When we compare the right hand side and that is of left hand side, the quantity is e to the power minus E upon RT, which is expressed in terms of that is of RNS equations, is now that is of a counterbalance. Finally, we have such important equations to define, to give the overall equations in our previous last video of chemical dynamics here. The students of M.Sc chemistry from semester 1. In our last video, in which the final equation which we have derived it, it provides to us the necessarily help contribution to explain, to deliver the mechanism, kinetics, dynamics of today's hydrogen-bromine reactions here. So obviously, when we derive in our last video, when we compare collision theory along with that is of transition state theory, finally at the right hand side, right hand directions, all the constant to define as such as R, this defined gas constant is a constant, H to define as that is a Planck constant, next one K star to define as that is of equilibrium constant here. So obviously the probability factor in chemical reactions is directly related to define the entropy of the reactions, activation of entropy. It is the final result of activated complex theory. I mean to say, probability factor is such important factor which gives us to explain the dynamic kinetics of bulk reactions and that is a complicated reaction, to explain the structure, mechanism, stoichiometry of the reactions here. Now I will teach you today about next one, the dynamics of chain reaction of hydrogen and that is of bromine reaction. Some important introduction, definition, important features I would like to teach you about chain reactions here. Chain reaction, basically students of M.Sc chemistry, is very special kinds of reaction in which intermediate species, transient species, unstable species are produced in the form of atoms, and free radicals will further after the treatment to produce, to lead and to that is of accelerate the reaction in the series of various other self-repeating steps are now started here. Next one postulate that is of about chain reactions here. These reactions were firstly proposed by Bodenstein, Frank, Rice, Hertzfeld between the year session ranging 1819 to that is of 1934. Later on, Christian and Kramers, these were the famous scientists who independently applied the kinetics on that is of unimolecular reactions. Next one, important features about that is of chain reactions. All the chain reactions involve various steps, that is of chain initiation steps, propagation steps, and that is of ending steps. Next one, characteristics of chain reaction. The probability factors for all the chain reaction is always generally to possess, to have the value of unity greater than that is of unity. Its rest that is of important features and postulate of chain reaction I will teach you involving by that is of hydrogen and bromine. It's the next postulates of chain reaction of hydrogen and bromine I will teach you tomorrow. Now permit me to join to you that is tomorrow. Till now you take care yourself. Thank you. Goodbye. Thank you very much.